Okay, since we have the Brainf compiler, let's try to write something in Brainf. Like let's make a small adder. And first, I wanted to implement it in C just to show you like the main idea because I don't want to make like adding 2 bytes between 0 and 255. I want to make it like work on large numbers, but we'll see. We'll first make it add 2 digits and then see how we can scale it from there. But I wanted to like try to do it in C just to showcase how you think about when adding to large numbers. So let's have this thing. Let's have the main function. Let's include this TTIO. First, of course, the hello world. Now let's GCC and yeah. So the format will be like you input the first number on the first line, the second number on the second line, and then let's see. So we are gonna have a char. First number will be, let's make it like pretty large. I don't really want to deal with allocations, so let's say the maximum will be 255 numbers or 256. Let's see. So yeah, let's not have any error handling or whatever. So we just read. So let's have here define max size. Oh, it's I guess. Ooh, okay, max size. Let's do it like that because it's faster, to be honest. Okay. So now, when we have a character like 9 or something, if we subtract 0, we get the the digit, okay? But as an int. So, well, first, let's say that um, yeah, well, we would like to convert the numbers, like the characters, to digits, right? So let's have an int for the first number digits will be max size and the second number digits. So then let's have a for loop for int equals, and let's okay, yeah, I mean even the length would be good to have. First number length equals strlen, but we need the string io, or I mean string, and the second number length. And here we go from I would put the numbers in reverse, but it doesn't really matter. Let's just convert the numbers to ints. Although we can do it in place in some way, like we don't even need to store the numbers, but like as an idea, right? So let's have maybe a char output max size. Wait, I mean actually, yeah. Let's no, let's keep these, and what if we go in the reverse order, because it's easier to reverse the two numbers and then go from there. So from first number we are gonna put the numbers in reverse. Okay, the second one is the same thing, but now we have the numbers in reverse. Okay, so result, we have max size. We also have to have the carry, just in case like we have a carry. And yeah, sure, let's have a result length. And now it's for int I equals 0. And we have to go until we reach either of the two numbers ending, and afterwards we just append the rest to our result. So here we do the sum, we add the two numbers and the carry to get the current digit, then the let's say like the current digit will be the sum modulo 10, and the carry will be the sum divided by 10. After that we have to finish up the first number. No, yeah, I should have said here int I equals 0 and then do it like this. And here for we can use j to finish up the first number, and then we can use also j to finish up the second number. So the idea is that only one of these will be executed, because only one of them is like only one of the two numbers is larger than the other, and if they are equal then neither will be executed. So yeah, now in result we have the digits. So basically we just have to print them, right? So we print each digit, and then let's printf like a new line. So now if we compile this thing, we input some let's make it like reasonable so we can do the addition. So I wasn't expecting that. Let's printf here each thing. Well, I mean, see, it's fine. Why? Oh, it's because of the new line at the end. Okay, so let's remove the new line. So like first number, second number. Like let's remove the new lines. Wait, am I? Oh, I didn't compile it, didn't I? No, actually I did. But what, you have to do another one? Hmm. wait, I don't think I get it. Oh, let's go from, because the length changed. Alright, like, yeah, let's subtract from the length. Okay, this is good, but it's in the reverse order. So, oh yeah, in any result we put them in, well, I mean they are in the correct order in the result, so wow, this gives me like, let's see the sum. Like we should see 6, 4, 2, right? With what? Wait, why did I think that? Hmm, I thought, oh, we didn't reverse it. I'm stupid. Um, we need to do it like this if you want to reverse it. It's like this was just copying the array, so we need to put that thing there if we want to reverse it. And it's actually minus I plus 1, minus I plus 1. Is it like we subtract? Well, I think it's easier to say here I, and then here let's say first number minus I, and here the same. Like it's easier to see it that way. And now adding the two numbers, yeah. Okay. And let's say if we add like 999 with 233, see, we don't get a carry, but if here, if carry, well, that's interesting because it will add it at the end. Oh, but yeah, the number is in reverse. So, as I said, 999, and if we add 333, we get 1332, right, which is correct. So, yeah, basically this is how we add two large numbers in C, basically numbers that are bigger than ints. Okay, we just iterate each digit, we add both digits, and then keep the carry and the sum. So yeah, now let's try to do the same thing. but we'll have to do it in brainfuck. So that's it. Yeah, and also I worked on a better checker for brainfuck. So okay, let's compile the main, and now let's have the adder.bf file. Okay, let's have the rules open because we might need them. So first I wanted to make the sum between only two digits, so we'll have two inputs and put them on a tape. So we use comma to input. So I would say that this should be the first step, right? Like we should have two inputs. I said adder, so this would be f minus o asm. Then we can do this, and then if we gdb example, we can break on start, run, next instruction. So let's say 5, then we go, the next instruction is 6, I mean the next input, and now at the end if we like inspect from like we know this address is the right one, we see the character codes for the two things, right? We see the character codes. So obviously the first step would be to subtract 0 from each one and get the thing. So let's see, Python, what is the character code for 0, 48? So let's generate 48 minuses, and basically this is how we convert. So let's go back one step, go on the first one. So we can say like read the inputs, go back on the first cell, convert first cell to digit. Now let's go to second number, convert second number to digit. Okay, let's see. I mean, the good thing is that since we okay, let's have okay, let me just copy paste this and put it after this thing so we can okay, now let's gdb example, break on start. Now yeah, I mean the thing that sucks is that we have to go through all of this each time, but yeah, as I said, the good thing that since we implemented the optimization is that it will add 48. Oh no, I it exited, so we have to go again. Oh my god. But yeah, what I want to say is that, but I don't know where it is. Like deck, see like 30, right? This is what it subtracts. This is moving to the left, and then subtracting 30. So let's put 6, and now, like before we do the syscall, let's show the tape. So we're gonna see a 6 and a 5. I mean, they are in the reverse order because it's little endian, but we have 6 and 5. Perfect. So now how I would do this is just move everything from the first cell to the second cell and add them, like mash them together. So we need first, let's see, let's go back to first cell, and now we should create a loop. So if we find a 0, like when we do opening bracket, we check if it's 0. So if it's 0, we are gonna go to the end, and at the end here we, like, if the first cell is 0, we completed the addition. So yeah, basically we completed the addition. So how do we do the addition? We subtract, then we go to the next cell, and we add, and then we go back, right? Like this. Move one from first to second cell. Move one from the first to second cell. Okay. And yeah, basically after this we have the thing. So let's see. Let's compile the example, and now let's break main as usual. Let's run it. Now let's give it 5. Let's give it 6. And now see, we entered the, let's print the tape first, right? We have it, we have that. So let's go next. Jump is not taken because it's not 0 there. We go, we increment whatever. Okay, so this goes, this will check if it's not 0 and jumps back, right? So now if we look at the tape, we should see 7 and 4, right? Then we go again, it jumps back. We do this one more time, let's see. Well, I wanted to see this. So now it moved 2 more because we did more steps. But again, it goes, and this one is the last one. So now it no longer so this is the last instruction to exit, and if we look here, we have a B, and the B is 11. So it added the two numbers together, and we got 11. So let's 0xb is 11. Okay, so I think, yeah, I wasn't really, it got me a bit of guard because it was actually like, yeah, this check, of course, if it's 0, but this doesn't jump to here, it jumps here. So actually this checks if we have jumps back if we have something that's non-zero, which makes sense because it's like to match the opening bracket. It does the same thing basically. So it goes back because we don't have a zero, and it completes the addition. Okay, so after this step, let's move to the actual sum. We move to the actual sum, and now it can be a bit more weird because we want to split it into carry and the sum, like we want to do modulo on it, modulo 10. So how are we gonna do that? Basically, my idea was to have something similar to this. We want to move one item at a time to another cell, but we want to do it like I think 9 times, because yeah, right, like if we do it 9 times, we move 9 items from the current cell. If we reach 0, then it means that the number, like the addition, doesn't have a carry, so we don't really care about it. So let's try to build this thing. So it will be like, if it's a 0, then we can jump at the end. There's nothing really that important. We did 0 plus 0, and the result is 0. We subtract 1, and let's move 2 steps to the right. Let's leave 1 space for the carry. Let's leave 1 small space for the carry. So we go 2 steps, we add 1, and we go back. And then we end it. Right, like this moves from the current cell. Yeah, I mean, we can also have like, wait, no, I wanted to open GIMP. So like, let's switch the colors. So like, let's say we have the tape, and here we had the first number, like we had 5, right? Here we have 6, and then we have zeros. So what we did was basically move from here, and now we have 11 here, and we are on this spot. And now we want to move here one by one, 9 times. So after we do all the, so like after one operation, we'll have 1 here and 10 here, and the other spots will be 0. And if we do it 9 times, here we are gonna have at most 9, and here we are gonna have the rest of the items, so like 2. So we're gonna have 2. But what if we try to do 10 moves. It's like what I would like to implement some sort of modulo and div, right? So that's what I'm thinking. If we try to move 10 and we have less than 10, we're gonna have here a 0. So probably we skip everything. And in this cell we have the result of the div by 10. Or actually it's the result of modulo by 10. But if it's larger than 10, like if we have 11, let's say, and we move 10, we are gonna have 10 here. And here it will be something that's not, it's not 10. I mean, we don't really have to generalize. We know that if we add 2 digits, like the maximum we can get is 1 and then like another digit that we want. So we can subtract 10 and then here we get, that's why I was thinking like we can move out 10 from the current cell. Let's just move out 10 items. Um, but it's like really weird because if we have 0, it means that this is the carry. But if we don't have 0, it means that this is the carry of our addition. Like what's left in the old cell. So yeah, it's pretty weird how. Yeah, because now I even get this question like, what even, like how does even modulo work, right? Like, so far I took it for granted that it gives you the rest of the division, but how do you actually perform that? Like in a, can you do it with plus and minus? Mm-hmm. Yeah, because now I was thinking that okay, now we have to move 2 here and 9 here, and maybe we can do something like go back to this one and subtract everything and then just move 1, or like move until we have 1 here. So yeah, if we move 10 items from this, yeah, I mean we can try to do that, and like if we move 10 items from here, right, we do this 10 times. If we have a 0 left, then it means that the number was below 10. So we have 0 and the digit. Well, let me, and the digit. And if we have something that's greater than 0, it means that we have to do this again but reset this to 0, right? And the carry will be 1, and we do the thing from above and we get 1 and the digit. So we can do something like we move 10, then we add 1 here, we subtract 10 from this thing, and we go back to this one. I think this is how we are gonna do it. Like, did it make sense? Hopefully. So basically my idea is let's move 10 from here to here. Okay, if we have something that's if we have 0 here, we stop. But if we don't have 0, we subtract, we do minus 10 in this cell, we do plus 1 here, plus 1, and then we do again everything. And this would work like this would be basically modulo 10, no, div 10 and modulo 10. I guess this is how modulo works. You yeah, I mean, I'm pretty stupid, obviously. You subtract 10 from this, and as long as you can subtract 10 from it, you get the division, you get a quotient, and after you can no longer subtract 10, you have here the remainder. Okay, that's how you do it. It's too early for me to be able to think. Okay, so actually let's keep it like this because it was a nice explanation for me. So we move this thing once. Let's and well, let's do it like 10 times, and let's do it here. 3, 4, 5, 6, 7, 8, 9, 10. We should have 10 closing brackets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. We have 10. So this moves from here to here 10 times. Shbalang. And of course, if it cannot move, at some point it just stops, right? Because let's say that we have 1, it subtracts, it goes next, it adds it, goes back, we find 0, and we jump at the end. Okay, so this basically move 10 from first, like from cell to over. So we move from cell to reminder. Let's put a space. We move 10 from cell to reminder. Now we should go back. And if this is 0, we can stop. So we go back to cells, and now we should have this thing, right? Like this. If we find a non-zero on the first cell, it means we have to go back. It means that we have to go back. But we should also subtract 10 and add 1 when we go back. So the question is, how can we do that nicely? Is it like we have to do this once and only then start with this? Is it like a do while loop? Let me think if it's a do while or not. So we subtract 10 and then while this is not 0. Yeah, I mean it could be a do while, like a while, sorry, like we have to do it once first before, and after that, if it's 0 we skip it, and if it's not 0, so if it's 0 we skip it, and if it's not 0 we subtract 10 from here, we add 1 here, we go back to beginning, and we do this thing at the end. So yeah, it would make sense to have this here, like we move, so let's say modulo 10, modulo 10 operation. So we move 10 from cell to reminder, we go back, then if we find 0, we skip everything. If we don't find 0, we have to go forward 2 cells, and then let's subtract 10, because it means that we moved everything with the, like if we find some, like if we don't find 0, it means that we went through all of them, right? Like we can subtract 10 from this. Let's go back 1 cell and add 1, and we go back another cell, we do this. Well, we don't have to go back 2 cells because we are already, each time we are already back. Okay, we move 10 from this to this. Okay, if it stops, then we'll have a 0. Then then the quotient will be whatever we added here, and in the reminder we'll have the reminder. And we'll be on the last number. And now the question is on what place do we want to be, right? Like to do the printing though, we should go, like now it's printing time. We should go forward 1 step on the, like on the carry place where the carry is. First digit, the carry. If it's 0, we skip it. Right? If it's 0, we skip it. But we have to add convert digit to int, like to number. We have to add this on top. Then we can print it and print. Okay, and if it's like, let's say, because now we're gonna have like something and it will go back, so we need to subtract from it until we have 0. Clear it. That's how you clear a cell, right? You subtract until you get 0. Okay, we clear it, then we go to the next one, to the next digit. Well, I mean, let's not think about the leading zeros actually, because it's gonna be too complicated, to be honest. So printing time is pretty simple. You just have to do this. So let's compile our thing and let's run it directly. Let's see if it's Is it like okay? Let's use GDB, but it's pretty weird with GDB because we have a lot of loops. Okay, let's go. So here we have a read. Here we give it 5. Then we have another read. We give it 6. And let's have a look at the tape. So it's 5 and 6. And now let's go through all the moves. Jump is not taken, so now if we look at the tape we should have 11. Let's go some more. It looks if it's 0 and it's not, so it subtracts 1 and moves it to the... Wait, I actually moved 2. Did I miss something? Maybe it was too fast, like it actually did 2 of them. That was blind. Probably, I guess. Okay, let's take a look. So now we should have 3 after this one. Okay, yeah, fine. Then I missed 1. So it goes, it should go through all of them. Yeah, like it should say jump is not taken for all of them. Jump is not taken. Oh, I forgot about something, I guess. So now it goes back. Yeah, damn it. So I think this thing should be put somewhere else. This part. So we do 10 moves, right? Then we have to check if it's 0. If it's 0, then we skip. If it's not 0, we have to do the actual modulo. So, well, this thing can go here. So if it's not 0, so if it's 0, we can skip. So this move moves 10 from cell to reminder. Then if we find a 0, we can skip. Yeah, it will go over all of these. Yeah, but if it's not 0, we go forward, we delete, we delete, um, we go back and do an addition. Then we go back one more step. And now we should, if we try to move again 10, from cell to reminder, what's gonna happen? So we're gonna move, like, now we will have a number that's less than 10 here, so this will actually finish, right? But if it's a number above 20, like, I don't think this works. Like, I don't think this is how you make modulo by 10. Like, yeah, if we had like labels and we can jump to the beginning, it would work. Like here at this point, we want to go here, but we can't. Yeah, like that would be the plan. But this, I think this should work now. Let's compile it. Let's GDB it. It's easier. Break start, run. Let's go fast. 5, 6. So this was, let's look. This is just the moving of the first cell into the second cell. It just moves everything. Okay, let's okay, now it moved it. And now we can move, like, do the modulo 10. So if we show it, yeah, it starts to do it. So let's go until we, I don't think it's done yet. Yeah, it still has to move some stuff. Quite a lot. Oh, he really did it. Like we have a 1 in this thing, right? It did like a subtract by 10 from our thingy, like here. So now it has to add 1 to the carry. So it adds 1 to the carry. Like to the third cell. And now it should do this thing. It should move the rest from the first cell to, now it should encounter 0 and take the jump. Jump is taken, it goes to the end. Jump is not taken, it jumps over all of these closing square brackets, over all of these, because it's a 0 on our current thing. Yeah, whatever. I was thinking of some random things there that we can try to do. But no, I mean, let's keep it simple. So we go over all of them. And now if we take a look at this, we should have a 1 and a 1. So let's move on. We add 30 here. So if we look, we should have 31. Okay, next instruction. This should print it. Was it anywhere? Yeah, a 1. That's good. So now it should add the 1 on the other one as well. and it does the syscall. And yeah, that's it. I think if we run example and give it, yeah, but I don't know how I can give two inputs like 5 and 6. Okay, you have to do it like this. Put the two numbers one by one. Okay, let's do one more thing here. Let's put this is for the new line. Okay, so example, and now if we have 5 and 6, we get 11. If we have 7 and 7, we get 14. This is really funny. If we have 3 and 3, you get 0, 6 because we don't handle the leading zeros. But yeah, like we could try to handle the leading zeros, but well, actually, it's just for the carry, right? Leading zeros. So I might have been fine by putting this thing here like this, like handle leading zeros. Yeah. And if we do 7, 7, 14, if we do 9, 9, 1 and 9. Okay, this is interesting. So let's say we have a 10 then here, right? What would happen if we have 10? I think it goes through all of these, right? Oh, but it finds here a 0. So then we don't even need this thing anymore. Because I said that we hard code the thing that it's just like, okay, wait, yeah, like it's a maximum 20, like for max 19. Like it's modulo by 10, but you have to have at most 19 here. So this is how we do it for only one digit, and it's really complicated. I can't imagine how you do it for more than one digit. Yeah. Well, I mean, I call this thing a success for now. Like, even if we don't manage to do it for multiple digits, I think it's still decent, a decent result. Um, so yeah, I mean, you can stop the video now. Like, don't you don't have to watch any further. Like, it's fine. We did it. We added two numbers. Yep, we added two numbers. Yeah, I mean, see you next time. Like why are you still here? No, you want me to suffer? No, please. No, we can talk about it. We can talk about it. We don't have to go this way. Okay, like okay. So that attempt was actually a fail, but I managed to at some point implement the algorithm correctly. So now if we run our main on the adder, and now if we run the example, if we say 1, 2, 3 and another number, we get the result. Yeah, it will have a leading 0 and both numbers need to be the same length, but I mean it works. It's like a bit of a compromise, but like let's say we have 99 and 43, and it also does the like carries it correctly. But if you have like 123 and you want to add 7, you have to put like this. It's a bit of a bummer, but I mean it was the only way. Like I was going mad, I I swear. So basically, let me show you how I thought about it. So let's say I wanted to expand on the idea that I had for adding two numbers, right? So I have here a marker. This means that this is the beginning of the tape. Then I put here digit, let's call it A1 as in the digit of the first number. Then we have B1, the digit of the second number, the first digit. Then we have some zeros. Now I experimented with it and I found out that we need like, I think it was four zeros, but I put eight just in case to have like nice padding of eight. So for each of these we need eight bytes, right? 8 bytes, whatever. For each digit we need 8 bytes. Then again A2 and so on. And then at the end I put like again an X to indicate the ending of the tape. Now, yeah, I really would have liked to do it like the way I initially wanted to do was have like the tape, here have X, then here have the first number, then another X, then the second number, and then another X, and then the result. But this way it didn't work. I tried, but it didn't work. This is what I tried the first time, and I failed. But now I've managed. I was trying to get some three-seater parser to work, but not really. So let's zoom in a bit. So yeah, first I set the marker. You do like a minus and you get 255. That's what I wanted to have as a marker. Then here this is like reading the input. Basically we move on the first cell like on A. Then we read it. Then we subtract um, 20 or what was it? Like this is the character code for space. If we check in Python, if we check the character code for space, we have 32. So yeah, I subtracted 32 from this character, and if we get 0, it means that we have the space and we need to go to the next number, right? So if we don't get a space, then we read in continuation. And here we skip 8 spaces to go to the next digit here. Okay, then we put a marker at the end. Here we put a marker. Let me just move this here because I'm used to having GIMP on 3. And we put the marker at the end. Then we move on the last digit I'd said. So that's like moving one step. And then this construction moves you all the way back until the first marker because it's like it adds 1, and if we had a -1 or 255, then it would jump over it. But if it's not a -1, then it would go inside and just loop by going to the left one step. And it doesn't change anything. It does a minus and then a plus, so it's not changing the stuff inside. And then yeah, makes it -1 back. So it goes back to the first marker. Then we move on the first digit, and after that we want to make all the digits between 0 and 9. So now we have a character code. So instead of having like 0, we have the character 0. So we need to make it 0. And since we already subtracted 32, we just need to subtract 16 more. Was it 16? Yeah, I think 16. We needed to subtract 16 more from the number to get it as a integer. Then we skip 8 spaces to match this. Uh, and yeah, basically this is the same construction as here. You see, like it's the same type of loop. So this goes until the minus 1 from the end. So yeah, then again we move on the last digit and go back to the start and go back to the start, right? Then we go to the right 2 steps. Basically we move where B will start and we do again the reading. And this time we look for the new line character, no longer space. You saw that I type the number in like 123, 123, and then enter, right? Like that's why. And the character code for new line is 10. So we had to subtract 10 from the numbers. And yeah, then we read again. And if we find the new line, we just stop. Then here I said another marker. It's like just having another X here, but it's useless, to be honest with you. So we go back twice to get on the last digit again here. Then we have the same construction again, which it's really gotten into my head right now. We go to the start. We move twice to the right again. We move on B1 and do the same thing, like convert it to a digit between 0 and 9. And here it's just like here we had 10, we subtracted already 10, we need to subtract 38 more. So this is 38 characters. You see here in the top right. And yeah, again, the same construction to go until minus 1 at the end. And this makes all the digits between 0 and 9. So what do you think? Let's try it. Let's do GDB example. Why not? So let's break on start. Let's run. Let's next instruction until we get a read. Let's do 99. Okay, let's put another 9, and now let's put a space. Okay, so now we should, like, if we inspect this thing, oh, let's put more let's put more things. So we see 25 is the character code for 9 minus 32. So yeah, let's go forward a bit. I'm not sure. Well, it's gonna be a lot, right? Can we disassemble main or something? I don't know how to write that. Start. Oh, we have this thing. Let's disassemble from this address. So can we go further like this address? Maybe even this. Well, what? Okay, I mean let's just break here and continue. So now we put the second number, which is 43. Okay, uh, let's see where can we have a nice break. Not really sure where. So this is where start begins. Let's look for the syscalls for reading. So we have read. No, that's not read, right? That's break. It's 0xc. Here we have a read, the first one, and the other read should be here, right? So the other read should be here, and let's now see. So we have a JE, which is like jump equal. Let's look for this thing. So let's put a break here, right at this address inside of GDB. GDB break. Let's put 0x. Let's continue. Let's run, obviously. And now we have to put 99 space 43. Press enter. What? Let's show the thing. So we have 942. The other 9. Something's not okay. Let's do obj dump again. So let's search. Let's search for syscall. So yeah, I mean, I thought that this would have been the right address. Oh, that's writing. But where's reading? Well, no. No, read is 0 in EAX. I'm sorry. So here is reading. Shouldn't have this. So jump not equal. So this is like the end of this, right? Like this was jump not equal in our code. So then we should have a decrement. We see the decrement. We see a sub by 2. Okay, so yeah, this was the right address. So we were correct. Let's see where we put the break. No, it wasn't correct. Weird. So let's run. Let's give it 99 and 43. And now if we check the memory address, we see the 9 and the other 9, and we see the 8 spaces that the first number has, the 8 spaces for the second one, the -1, and the other -1, and 42 and 41, which are the character codes. And yeah, now yeah, if we go forward, you'll see like I don't know how much we need to go forward. Let's break. Let's look again at obj dump and what would be interesting further on. So as I said, this makes all the digits between 0 and 9. This moves on the last marker. Here we move on the first digit, and here we are on the first number. Right, like maybe somewhere around here would be interesting. Let's say So to be able to add the numbers together, so let's say we have all the digits, we'll go later on between on the like algorithm and see what happens. We want to add them from the back, let's say. So what will happen is we'll go to the end with the same construction basically, with this loop. We move on the last digit, but it's not really on the last digit, it's like here on the last byte inside our what's it like 1 kilobyte is not no don't snitch on me that I said that. So we have 8 bytes here and we move on the last byte. Okay, then we have to move by 7, so we move from here until the start. We add what do we add? We add here I said we added 2 numbers. So first we want to add the carry to the number. So we go forward. The carry will be at this position. You just have to trust me. We have to go forward by this thing by 12. And if it's a 0, basically we don't care. But if it's something else, then we just add it and we subtract 1, we move back, we add 1, we move back again, and we continue until we have 0 in the carry. I mean the carry will be 1, but just in case we have 2 or 3 or whatever. Then we move back on the first number and then we add the first number onto the second one. So we take the carry from somewhere in the future. For the last digit it will always be 0 because the tape is 0. But we take it, we add it here, and then we move A2 into B2. This is B2. We move it there. Okay. Okay. Then we have to put 10 on the tape here. So here now we have 0. Let me just make it a bit cleaner. So here now we have 0. Here we have A plus B plus the carry. Okay. Here we are gonna have a 10. We'll see. You'll see why. Then we'll have a 1 in the next one, and then zeros. 4 zeros. Okay. And the reason why is that I cheated and found the div mode algorithm. Basically, that's when we need so many spaces for each cell. We actually need just 6, but I wanted to put 8 to be aligned and not have to. I don't. It doesn't really matter because the only place where it matters is when reading. But we have the div mode algorithm. I have no idea how it works. So yeah, basically we do the div mode, and here we are gonna have a 0. Here we don't care about this, it's just trash. Then we have the the modulo, but it's +1, so we have to subtract 1. And here we have the quotient, and then we have zeros for the rest of the thing. Then we need to actually set the and we stop, I think it was on this thing. This is where our pointer will be, so on the gibberish. So we move to the right twice, we go bam bam, we oh no, yeah, we stop on 0 actually, because yeah, we go to the right twice, bam bam, we subtract the 1 from here because I don't know, it just has 1 too much. Then we need to go to the last digit of the next number, so now we are here, so we need to go 1 2 oops. So we are here. No, we are here, right? Yeah, why do we go 4 steps? I thought, no, no, help me, help me, please. I'm gonna miss it. So it's one step, we get here, second step, third step. It's weird, but it works. It's weird, but it works, which is even weirder. Okay, let's test it. Let's test if it works without the thing. I mean, it shouldn't. So yeah, like maybe maybe it was like an extra zero, but I don't remember exactly. I think it's an extra zero. Like it's not really like this. You get when you do the div mode, you actually get 2 zeros, and then it was the gibberish, and then +1 and Q, and then you are here. You go 2 steps. Yeah, yeah. This was like that. I remember from the GDB, it was 2 zeros. So you need to go back 4 steps to get on the last byte of the next sequence. Okay, you need to go 4 steps. It's a bit misleading. This comment it should have been. Whoa, but it's here on minus. See this? Like it's so weird. He put a minus in the comment. The guy that where I copied this from. Let's see, because it shouldn't have a minus there. I mean, it's on the gibberish stuff, so we don't care about it anyway, right? So it can be like whatever he wants there. He can have whatever. But yeah, I think it should be 2 zeros here. Okay, anyway, it's 2 zeros actually, yeah. Then this is like the same type of loop. Yeah, again, the same loop. So annoying. And it basically checks if we find the marker. So the next time it will do this one, and then when it goes 4 steps to the right, it will stop here, right? And when it does the plus, these things turn to 0. It finds a 0, it exits from the loop, it does the -1 to make it back marker. We go to the carry position, which is why we always show the what's it called, even if we print. I put a 9. Even if we put 1 and 1, we still get the leading 0 because we always print. We could have like mm, we could have something like this, right? And this will no longer print leading zeros, but yeah, actually, let's leave it like this. Wow, good thing I decided to do this. So because here, if it's 0, then it skips this print, right? If it's not 0, it enters here, it prints the whatever it has to print, then it makes it 0, so we can exit. Okay, so it makes it 0, so we can then exit, because we no longer need this thing. Then we go to the start of the first number, so we go back 4 steps. Again, this is like the place where the remainder was, so we need to go back 4 steps. Okay, so that we can check again for the marker, again the same loop. Then we need to go to the quotient, whatever, 3 steps forward, so here basically to Q, we have to add, oh yeah, and this crap right here is basically the character code for 0. We have to add 48 to each digit to make it character back. We add the character, we put a plus, and then we have to go to the start of the next number. So if we are on the quote, I forgot where it was, like on the fourth element or third element somewhere, we need to go to A2 now. So we use 5 arrows and then the plus and the thing. So it checks for -1. And yeah, basically it goes next, and then at the end it comes on this X right here, and it sees that it's a -1 and it exits. Ah, incredible. Let's obj dump this scheiße. Let's obj dump this and gdb example. Let's break here right at the end. Right at the end, let's put 43. And now if we look at the memory, we should see some crap. So see, it's like 2 zeros. As I said, it's 2 zeros. Then it's the character code for 4 or what? I think 4, and this is for 2. Let's check in Python. Let's check in Python what chr this is. It's 4. So yeah, basically it converts them. See, like it's the fourth thing here, and here we had the remainder, but we made it 0, so we don't print leading zeros, right? So yeah, basically we made a fucking brain fuckerino. So let's do like a really big one, 9 characters, and let's add 1 2 3 4 5 6 7 8 9, and it can add numbers there. Oh my god, this is amazing. Yeah, so I think I'll just cut out the fail part and just put this instead at the end. So bam, yeah. I guess next time I'll showcase how to install the Hyperland and NeoVim and Timux. It should be pretty easy. I mean, I hope I'll get some errors and be able to fix them on there. Otherwise, it will take like 5 minutes to install it, I think, because I have installed scripts for them. And oh yeah, actually, it will have to install all the dependencies, but don't worry about that. I'll try to fast forward through them. So yeah, see you next time.